Hi everyone! In this video I'm going to give an introduction to generating histograms from data using matplib. I am currently on the NumPy arrays and Python notebooks reading page, which is linked on the course website, and I'm actually just going to jump into the histograms and binning reading here just to take a first look. So if you have been consulting the readings, you may have already seen that these are Colab notebooks again, so that means you can actually run the code inside of them. And so if you have not been consulting the readings, which is fine, you won't know what this matplib inline is doing, but what this is doing is just allowing the matplib plots to just directly show up in the notebook. So that's kind of nice, but not required for this class. And you won't turn in any notebooks, so you don't need to worry about that if you don't want to. But the big idea here is that if we want to create histograms, which just show us the counts within bins of our data, there's a very simple matplib command, plt.hist. We pass in our data set and we generate a plot. So I'm just going to go ahead and run this here. I get this warning from Google, but that's fine. So what's happening here, we are creating 1,000 random numbers from a normal distribution, actually. A normal distribution is that bell curve that you might be familiar with. For this class, you don't need to know what a normal distribution is, but just know that we're generating some random data from this bell curve kind of distribution. Then, once we have this data, we can just call plt.hist, and matplib automatically generates this histogram, which is really nice. An important parameter of plt.hist is bins, which is the number of bins that you want to see. By default, it's 10, but let's just say we wanted 50 bins, and let's run this and see what happens. So you can see those bin sizes got smaller, and so we get a more detailed picture of the distribution of our data. And in the book, we also see a sort of fancier version of a histogram where we're specifying an alpha, which is how clear, like if we want the color to be sort of like clear. So that's between, alpha is a number between 0 and 1, where if it was 0, it would be sort of totally transparent, and if it's 1, then it's not transparent at all. Setting a specific number of bins, setting a specific color, as we've seen, and here this edge color attribute is specifying whether we want these black lines around each one of the bars. And so I believe that when we run this, we actually get an error, and this is a great opportunity to look at the Python documentation. So the reason that we're getting an error here is that we can see it says polygon object has no property normed, and so it turns out that the normed parameter, let's look for it here, normed. The normed parameter is an old version of the density keyword, and so if we change this to density equals true, this is telling Python that I don't want the counts per bin, I want a plot that has the property that summing the area under the curve will be equal to 1. So that's what that's doing. So the book also shows us how we can plot multiple distributions on one plot. Again, to run this, we would need to change this keyword to density, and then we can run it and we create that plot. But that's not going to be something that you need to do in this class. That's just some extra information. But I do definitely want to point out this documentation, which can be useful to get the histogram that you really want to get. So now let's check out, we'll go back to the web page and let's go ahead and check out activity 2. If I can get down there. Oh, no. Activity 2 from the matplib reading, which is Dice Simulator. I'll just save this and then I will open it in idle. And the big idea here is that we're going to simulate rolling 2 dice, and we will plot using a histogram the frequency of each result. So I'm going to run this, and we can see, what are we seeing? We're seeing 3 of our experiments had a total of 5. So I believe these are 6-sided dice. So how do we get a total of 5? Well, that's going to be, we had a 3 and a 2, or a 4 and a 1. In this, there were 2 occurrences of a 4, etc. And so how are we actually generating this data? Well, we call the generate roles function up here, which gives us back the resulting numbers. So the data for each role. Maybe we go ahead and print out that, just so we know what data we're inputting to our plot. So here, let's go ahead and check. We had 2 7s, and we had 1, 2, 3 7s, and that's why we have 3 under 7. We had 1 10, that's why we have 1 10 right here. And so our data is the sum of each of our rolls, because we're rolling 10 times. Let's say we increase this to 100, and we run it. Now we're going to get more data. And we see that we have a sort of more accurate representation of the true distribution of rolls that you would get. There we go. So that's how we're generating the data, is generate rolls. How are we actually plotting? Well, it's this plt.hist takes in the rolls data. We're setting here, this is, instead of setting the number of bins, we're actually setting what those bins should be. So let's actually print out what we're setting the bins parameter to be. So when we go to set the bins parameter, we're passing in an array of 2 through 13. So before, we'd only seen that we can pass in a number of bins. So let's try, what does it look like when we pass in a number of bins? Let's try a bigger number so we actually see a difference. Well, so because there are actually only 13 total values that we can take, these bins are very small, but our data, like even though there's a bin from say 10.1 to maybe 10.2, we have no data in that bin because all of our bins are just whole numbers. Another thing we could do would be to set this to a very small number, and we'll just quit Slack here. And now we only have 2 bins. But originally what were we doing? We were specifying what those bins should be instead of giving a number. So that's something we can do with bins. Here we're just giving some more parameters for how the plot should be generated, and I'll let you consult the documentation if you want to understand these. Then we're setting the X ticks. So that is saying what should actually be labeled here. So let's try commenting this out and seeing what happens. So without that command to where we passed in the NumPy array, so this command was, we passed in a NumPy array of the integers 2, 3, 4, all the way to 12, and that was setting the ticks, which are these little lines that come down. Those are called ticks. So these are the X ticks, these are the Y ticks. So this is setting the X ticks to happen at all 2, 3, 4, 5, etc., all the way to 12. By default, matplotlib is only putting X ticks at 2, 4, 6, 8, 10, 12, etc. So again, if we go back and we run this, now we have X ticks at 2, 3, all the way to 12. And if you were confused when you saw that, you might just do something like, look for X ticks. And I guess that's matplotlib pyplot X ticks. And then we would get to the matplotlib documentation, and we would see that this gives us the documentation for this X ticks command. And here we can set the current tick locations and the labels of the x-axis. So if you both wanted to set the locations and the labels, you would need to pass in two parameters here, I believe. And here we see we're setting the X label, the Y label, the title. This command is what's providing this grid. So if we remove that, we would have no grid here. And that's what we see. So that is a histogram for you. If you have any questions, please post in Slack.